Hello everyone, I'm lead meteorologist Thomas Wasula from the National Weather Service at Albany, and I'll be covering part 4 of the Spring SKYWARN session from the National Weather Service at Albany on thunderstorms in terms of damaging winds and tornadoes. Damaging winds. How do they occur and why do they occur? On the left side of the image you see a cross section of a thunderstorm with a cold front moving in, and you see initially a thunderstorm is in the initial stage dominated by updrafts. This is the cumulus stage. In the second stage, step 2, you see updrafts and downdrafts side by side with a mature thunderstorm. Finally, as that thunderstorm further matures, you see a full line of thunderstorms with very strong updrafts and then downdrafts coming down potentially at the system as you see the movement of the cold front. When these downdrafts come down, they could be dry or moist, could produce damaging winds, which is the most common wind damage in the National Weather Service at Albany's forecast area that covers eastern New York and western New England. Now let's review a video on damaging winds. That was a great review on damaging winds from downbursts to haboobs. So let's look at some of these winds in a little bit more detail. Damaging winds are the most common, as I mentioned, across the National Weather Service at Albany's area. You can see here winds of 58 miles per hour or greater, or 50 knots or greater, can take down large tree limbs, take down whole trees, power lines, destroy property, damage siding and roofs and fences. Here's a case from May 4th, 2018. We had a line of strong to severe thunderstorms with lots of wind damage that are produced across the forecast area. There are two types of winds in terms of scale, microbursts and macrobursts. First, a microburst is a small downburst of wind with an outflow less than 2.5 miles in horizontal diameter and lasts up to 10 minutes. Despite their small size, microbursts can produce destructive winds exceeding 100 miles per hour. Macroburst is just larger in scale. It's a larger downburst with a horizontal extent more than 2.5 statute miles in diameter. It can last up to 20 minutes. A macroburst is typically not quite as strong as a microburst, but can still produce destructive winds leading to tornado-like damage. Here's an example of a microburst from one of our spotters, meteorologist Holly Alswell, in the I-90 corridor near Castleton, New York. You'll see the downbursts come out of the thunderstorms toward the end of the video here. You see the updraft, some scud, and you'll see kind of a sheet of rain come down. Right there at the very end. That was the downburst coming out of the thunderstorm. And now you're losing all visibility in the wet microburst type of situation here. A derecho is a long-lived windstorm that can move over several miles and produce widespread destructive wind damage. What is a derecho? Widespread, long-lived windstorm made up of rapidly moving thunderstorms. Often can cover hundreds of miles and last multiple hours. One such derecho occurred in the fall in 2020. There were over 100 reports of wind damage across eastern New York and into western and central and eastern New England. The wind damage swath must extend more than 250 miles and include wind gusts of at least 15 miles per hour or greater along most of its length. Then the event may be classified as a derecho. And as you can see from the image, the wind damage started east of Lake Ontario across central New York. It moved down the Mohawk River Valley, much of the Hudson River Valley, into western New England, and even as far east as near Boston and eastern New England. There were a couple of tornadoes, but overall, 100 reports in our area. I think overall is almost 200 across the Northeast. Now let's review tornadoes. The first thing that mentioned before the video is what a funnel cloud is and what a tornado is. A funnel cloud comes out of a wall cloud. It must be rotating, but it is not touching the ground. A tornado is a rotating column of air that does touch the ground, and you see debris spin up. Sometimes you don't see the whole condensation funnel touch, but if you see that debris spun up with 3/4 of the way down, it's a tornado, but it must be in contact with the ground. Now let's look what causes a tornado with this video.
What causes a tornado? The swirling, funnel-shaped winds of a tornado are easily recognizable, and they can be very dangerous. But what causes these unique and violent weather phenomena? Tornadoes usually begin with a thunderstorm, but not just any thunderstorm, a specific kind of rotating thunderstorm called a supercell. They can bring damaging hail, strong winds, lightning, and flash floods. Supercells form when air becomes very unstable and wind speed and direction are different at different altitudes. This condition is called wind shear. Wind shear is common in the formation of most thunderstorms. When wind at ground level is blowing in one direction and wind higher up in the atmosphere blows in a different direction, it can cause a horizontal tube of air to form. In a thunderstorm, warm air rises up within the storm. This is called an updraft. An updraft can turn a horizontal rotating tube of air into a vertical one. When this happens, the whole storm begins rotating, creating a supercell. Some supercells form a funnel cloud. And if that funnel cloud extends to the ground, it's called a tornado. Tornadoes can produce winds up to 300 miles per hour at the surface, making them dangerous to people and property. As a tornado moves along the ground, its strong winds begin to pick up debris too. In fact, flying debris is usually what causes the most damage in a storm. Thankfully, meteorologists are keeping an eye on your local weather. They will try to give you a heads up if a tornado is likely to form in your area. They combine wind and temperature readings from the ground with information from satellites to determine if your local weather has the right conditions for a tornado. For example, NOAA's Goes East satellite captured this video of an isolated supercell storm in Texas. The different colors represent different cloud top temperatures in the storm. Colder temperatures represent higher cloud tops, which often means stronger storms. So, if you see a tornado watch or warning in your area, look for updates and get to safety as soon as possible. And know that NOAA's GOES-R series satellites will still be keeping a close eye on things from orbit. Find out more about extreme weather at NOAA SciJinx.
Okay, that was a great video reviewing how tornadoes form, that you need that wind shear and the tilting and stretching of the column to produce the tornado and the subsequent impacts of tornadoes and supercell thunderstorms that produce the majority of the tornadoes. So let's review some tornado terminology first. First, in terms of the Weather Service, when we issue a tornado watch, that's issued with collaboration with the Storms Prediction Center in Norman, Oklahoma, and neighboring offices. And this means that weather conditions could lead to the formation of severe storms and tornadoes. Be prepared, know your safety locations, be ready to act quickly if a tornado warning is issued or you suspect a tornado is approaching. Again, watch means that it's possible. Doesn't mean that it's imminent or will occur. A tornado warning is usually issued when a spotter has spotted a tornado and maybe let the Weather Service know we issue a warning, or it's indicated by weather radar. Majority are indicated by weather radar, meaning a tornado is occurring or expected soon. Take action. There is immediate danger to life and property. Immediately seek refuge in a safest location, which usually is your basement, but could be an interior room like your bathroom in a home. And then a tornado emergency is kind of like the worst kind of situation and warning. It really is. It's an extremely rare situation with a severe threat to human life and catastrophic damage due to a violent tornado. Take action. There's immediate danger to life and property. Immediately seek refuge in the safest location possible. When we're talking about a tornado emergency, it's usually associated with tornadoes in enhanced Vegeta scale in the EF 3 to 5 range. Tornadoes get rated with a storm survey after the event. Okay, and we'll talk about that briefly. So, how are tornadoes confirmed before that rating? Well, the tornado warnings are issued by your local National Weather Service. Meteorologists in step 1 gather the information from emergency managers, storm spotters, and the public. If you have any pictures or videos, please share them with the Weather Service. So when the storm damage survey is done, this is the first step. The second step is that you plan a survey. Use the information gathered from the Weather Service meteorologists to decide which locations to send storm survey teams. The number of teams depend on the extent of damage reports, usually no more than 3 teams per day. At the Weather Service at Albany, typically 1 team or 2 teams are deployed, depending on the amount of staff available. And again, sometimes you do this with emergency managers. Sometimes the public will be involved if it damages their location. And occasionally there may be someone from the media that may be at a particular site or following along. When you conduct a storm survey, that's the third step. The Weather Service meteorologists travel to impacted areas to assess the damage. Some preliminary conclusions can be made based on the type and severity of the storms using damage indicators. There's 25 indicators that we look at. Once all the information is gathered, then the report of conclusions is brought back to the Weather Service and disseminated out to the emergency managers and the public and media. The Weather Service will assess all the data, consult experts, and write summaries and reports of the findings and tornado ratings. This can take hours or a few days. With major events, it may take multiple days, even a week or more, and extra personnel can be brought in from Eastern Region headquarters or national headquarters of the Weather Service if the scope of the event is extremely large. Let's review again a little bit of tornado safety, the do's and the don'ts. The do's, if you're in a car, is to get off the road. The best option is to drive to a designated shelter, basement, or safe room. Another do is the best option may be to get an interior room like your bathroom, a hallway, and the lowest floor. Stay away from windows, but again, if you have a storm shelter or a basement, that is the best location to be in. What to not do is seek refuge in a vehicle outside or under an overpass. Yes, some people have survived, but it's extremely dangerous. People can be killed or sucked out from an overpass. So do not do that. Do not stay in your car in an overpass. Do not seek shelter under an overpass or tree, again, emphasized by the bottom bullet here. Puts a greater risk of being killed, seriously injured by flying debris from the powerful winds of tornadoes. So again, these are some safety tips. And then here we have on the left side, bad options, and the right side, good options. So just to review from left to right, when a tornado warning is issued, mobile homes are dangerous. That's why if you have a storm shelter or a sturdy interior room or someplace to go, that's better. Vehicles are not good underneath highway overpasses. Not so good options have been shown that large open rooms like gymnasiums and manufacturing housing are not very good either. Many people have been injured or lost their lives in those situations from reviews of major events. Good options are interior room, a well-constructed home, or a basement. Again, this tends to be the majority here in the green that people have to stay in for tornadoes. Best options above or below ground storms, tornado storm shelter are specifically designed FEMA safe room, but many people don't have this option. If you do have a storm shelter, that can be the best ones. But again, your basement or interior room, like your bathroom, are good locations to go to. Let's briefly review the Albany climatology for tornadoes. This is the county warning area climatology, which covers eastern New York and western New England, southern Vermont, the Berkshires of Massachusetts, and northwest Connecticut, and much of eastern New York. Typically, we average about 3 or so tornadoes a year. Last year was an exception in the Albany forecast year. We had 11 overall. A lot occurred on July 16th. You can see that we've had major years like 2020 where we had the most, 14. But some years we don't even have any. So we average about 3 a year when looking at a climatology from 1980 to 2024, and that's about 45 years. What month do they occur? Well, in this 45-year climatology, the majority occur in this late spring into the summer, with July being the most, May the second most, and August the third most. They can occur in the fall and in early spring, but generally it's the late spring into the summer. Most of our tornadoes are EF0 or EF1, 89%. The majority tend to be EF1. These are generally winds of 86 to 110 miles per hour, and EF0 is 65 to 85. We can have the occasional EF2, and we've had like Mechanicville and EF3. They can happen, it's just rare because we just don't have the instability and shear come together just like they have in parts of the plains, Midwest, and the deep Southeast. So we still get tornadoes. There were a lot last year across New York. We had close to 30 in that big event, a lot of them. But again, usually in our forecast year, about 11 a year, and 135 occur in the last 45 years. And this is just a map to show you all the tornado tracks back to 1950. Notice most of them are EF0, EF1, a few EF2s. Then there's that seldom EF3 or 4, but usually, the big EF4 occurred in 1989 from Montgomery County down through Schoharie, Albany, into Greene. You can see here the EF3 Mechanicville is the orange here. We do get them occasionally, but they're rare. And then you can see that they can occur. They occur more. There may have been a few in the mountains over the time, but again, generally in the valleys where the people are, where they can be seen and the impacts occur. They can occur, but again, they're usually on this EF0, EF1 scale. So that'll conclude the section on winds and tornadoes, and I hope you found it very interesting.